Okay, so as a thanks for the opportunity, here is the fun fact, like Google saying, unusual activity on this network. Yeah, duh. So, we are always in a hurry, like this dude, you know him. And we're here to talk about, why doesn't it pause? Pause. Yeah, okay. Data storage. Data storage has been an issue for a long time. There's the time it takes to store it, the time it takes to move it about, and the time it takes to retrieve it. So these are my and Rob notes. I'm sure you know about them. Then a bit later in history, we have, these kind of instruments, barrel organs, which came pretty much at the same time as in industrial looms. That was 18th century of some sort, and they used punch cards. Punch cards have been used for a long time. There's a really beautiful machine you can see over there. I think it's some kind of telex. It's nice, so some internals. Not gonna do the whole story. Obviously, this guy, you know, some people can argue it's a step back in data density, but we'll just give him the credit. So, data is a bit, I see it a bit like light. Some people say that light is, don't spoil me. That light is light. Light has this infinite speed. And the more energy you put in, the faster you can go. But if you take one photon and you put more energy, like the entire amount of energy of the universe, the photon never reaches its light, and then the energy has been depleted of all its energy, so it doesn't exist anymore, and then there's nothing to measure the photon from, so we have an issue. And I see it something like this. So for this, we can consider that infinitely enough storage is as much as we can fill before it deteriorates, and as long as the data is useful, because obsolete data is like garbage, and we don't want this. We have been dealing with tape storage for a long time. There was talk that this would become obsolete, but it turns out that regarding cost and stuff, and yeah, it's still not dead. Can I do this? No. Okay. So I'm going to take a bit of a document that my friend prepared. So STK have been the best with their CS400 powder horn machine. They were ex-IBM engineers, and they almost failed, but they did pretty good things. They had this machine, like a hexagon shape. I can probably show it quickly. No, this is not working. Never mind. So, yeah, thanks for me forgetting my laptop. Where is this? Vas-y. So this is a machine he actually got, saved from the trash. It's a few tons heavy. You can really walk in it. And it had this problem that the robot had power rails, and I mean, it's a I don't know if you can see here. You actually have the power rails here, and the robot is moving, and the rails were used for communication. But after a while, what happened is that there were some fake contacts, and the robots would get stuck, and you would lose communication with them, and they would just disappear. It had this good feature that one robot could push. There were 2 robots per stage, and they could actually push the next one in case, and it was a decent workaround, I guess. But at some point, the machine really started being buggy, and it was discarded. There were a lot of attempts to do the tape storage. One of them was actually involving a 6-axis industrial robot that was designed to paint cars, and they ended up putting it on a little car to use a 400-kilogram machine to move around 400-gram tape. So it was a bit ridiculous, but impressive and fun. It was a very large machine, 28 meters long. And this didn't work, but the storage stack robot was actually pretty good. And it turns out it was the machine computer appliance that stayed in usage for the longest time, or one of the machines that was used for the longest lifetime. Okay, so for this retrofit, we had to do quite a few things because there were monolithic electronics, and the friend had to rebuild the main board. He made something much more modular. That's still the original board here, we can see. So that was a big work. And one of the things, and before I continue, not to spoil things too much. No, that's here. Some people have received something like this yesterday night. Is anybody here, and did they manage to figure out what it was? No. So the machine uses motors with Hall effect sensors, and there are 6 ways to connect the sensors to the motor, basically, because you have the phases, and then the sensors are basically rotated or inverted. And the friend was trying all the combinations, and you cannot do all the combinations. I mean, not all combinations are valid, and it's a bit of a brain tease to do it correctly. So he asked me to build himself a device to help solve the issue, and we couldn't find switches that had enough poles that were available. He was thinking of using a microcontroller, and I came up with this solution. Unfortunately, there's no camera, and this is basically some decoder. There's a ring that goes on top, and you turn it, and it tells you how to set the jumpers to get the correct arrangement for the sensors. So potentially it saves you at least an hour, and then you can do the operation in a few minutes. I was not able to order all the components. Like, there's a few pogo pins that are required. My intention is to send them by post if required, and if you want to support a project, you can come and buy one for whatever price you feel is fair. So yeah, I'll be around here later. Okay. So I'm gonna put a few more things. So that's the machine that's moving. One thing that was interesting is that my friend replaced the barcode reader with a decent camera, so we can read QR codes and do other things. We had quite a bit of issues because the signal for the motors was disrupting the video flow, the stream. So this is why we have some. Well, we don't see it too well here, but we have some pretty good shielding, yeah, on the flat cables. Another thing, what do you think is the fastest way to move data from this computer to the one he doesn't have? Some would say fiber optics. I say no. Take out the hard drive and throw him to him and plug it in, and that's it. We just transferred a few terabytes in a very short time. Why is it Z? Why not? Similarly, if I just did the calculation for the fun, if you take a cargo ship and you shove hard drives in it, you basically get 1,000 times the bandwidth of the transatlantic fibers for about the thousandths of the cost. But the bandwidth obviously is, not the bandwidth, the ping times and latency is really bad. But we get this kind of magic 1,000 by 1,000 and divided by 1 million, so we're close to a constant. Always depends of what you use and how much stuff you want to move at the same time. So the idea for the robot was that the end customer would be, because the end customer doesn't have a tape drive, these are really costly and they're cause an entry like you cannot easily have tapes because it's like $5,000 for a drive and this is not cool. So instead, we designed these boxes with it's basically PCBs soldered together. Inside we have standard hard drives, and there's a standard USB port for the end user, so you can get the hard drive, bring it home, do your backup, give it back to us. We put it in the robot, and then we have some pogo pins in the special bay we have designed here. So, that's not the right. That should be able to, it's really easy to put in, really fast. When the robot puts it in, it's really quiet. I was really happy with this. So my friend asked me to do this. The box was quite easy to do. And then I did try to do something like this. And I was like, yeah, I'm just so happy because it can just fit into a 5.25 hard drive bay. And then it was like, no, but I want them to mesh together to save more space. So basically you can plug them in like this and compare to I have a picture here. It is, so that's the components for the boxes. We ended up putting some active electronics that switch the signal from the end user port to the pogo pins. Because of the interference, it turned out that doing USB 3 is tricky. We found some really good documentation, but quite late in the process. I would have shown you, but yeah, I don't have my laptop, he said. So these are the boxes in use. One problem that we ran into is I took this video when the first time it worked, and it was on the last day for a Subinica talk. So I was like, yeah, let's show something. Well, we did something, and actually we failed. The weirdest problem we encountered is that when we mount the drives read-only, we have a decent throughput, but when we put them read-write, we drop by, like, we get down to 5 megabytes per second read, instead of hundreds or something like this. So we still haven't figured out. We're trying to look. If anybody has an idea, we're open to it. So prototyping to make sure the robot could hold it, so we're just dead weights. Let's see. I can hear this guy. Come on. So yeah, these are the drives that were in the machine originally, and in comparison, that's what we have. So it's a bit cheating because the tape doesn't have the actual drive inside. We're actually shipping drives and storage, but it's quite cool, and it's supposed to be really cheap, the boxes and the drives. So one thing that I've been having an issue with is when you buy those removable drives from the internet, you always get the set with the box and the device and the trays, but you cannot buy the trays by themselves. And when you want to swap a drive, you need to take out the broken drive, unscrew it, and put it back. And we're trying to do something else, so you can have just drives and plug them in and out, and have offline backups, also on site, not at the providers. So we were trying to figure out this USB issue. I have a little bit of a screenshot here. So yeah, 4.6 megabytes when it's read-only, and then we got over 100 when it's just remounted read-write with no wait time, no nothing. I mean, we just don't understand. And this happens with pogo connectors or just with the normal short USB cable. So yeah. We are going to put all the code on GitHub, so people can play with it. It's functional. We've done a few thousands of moving cycles, shuffling tapes around, and it works pretty well. We're about to some 90 movements per hour, but we haven't been doing much tuning of the speed, so I guess not too bad. So this will come. There are a lot of things that are still to be done. One of them is software to optimize where to put the tapes in the robot, because tapes that need to be accessed frequently need to be close to the drives, and there's like a sweet spot of what to do. The idea is that there are a lot of such machines that are reaching end of life. They're going to the trash, and it's sad. So hopefully we can get together and do something cool. Because if the machine at some point is broken, I've seen some excellent engineering, like very impressed with the work the guys did, assembling it, disassembling it, all the guys who did the special plastics for the lubrication-free, and it's just beautiful to work with such hardware. That was really a pleasure. So anyway, by the time these machines are mechanically broken, at least we have the software to drive the new open hardware ones. I have a small video made by my friend there. Where did it go? Where did it go? Disappeared. No, here, yeah. So, do you have music? You muted the didn't unmute the audio, I think. So, still no audio? No? No? Okay. Can we get the audio back from the aux? I think it might be playing, but should be louder.
Try turning up the video.
Well, I'm already on full there.
Try that.
I'm on 100%.
Oh no.
And when we tried, we had the ad at full blast. That should be louder.
It's going to the HDMI.
Oh.
I think it is not detecting the aux cable.
But we had the ad before. This is so strange. What's up? Because this?
Yeah.
Oh, wait.
Yeah.
Yeah, wait. We're getting there. I'm just so bad at Windows. I haven't had running Windows for 15 years, if not more. So, where is this? No. Okay. Well, he's gonna be upset because there's no.
Can we try just unplugging the aux one more time? Try one more time.
Yeah. It is. Murphy's Laws. Okay, so it was kind of silent movie style, so I guess we're just missing the little piano. Yeah, one thing we did is, or he did, was to add batteries. Currently we're doing communication Wi-Fi, but the plan is to do some optical guides and to make it really safe. Je vond geen piano van de muziek. Yeah, so it's quite funny. The end stops in this machine are just fake tapes with a code that says end stop. So yeah, that was the thing. Okay, so
is there like one or two questions? I think we can probably there's a mic, please, on this side. Just go to the mic, and on question on this side, I will take over here. Just go forward.
Anything yet? Okay. Why USB and not SATA? Why did you use USB for the connectors and not SATA? I'm curious.
Not what?
So you could use SATA hot plugging
Oh,
for
yeah,
plugging and unplugging the drives. It's like a less finicky protocol.
The idea is that the normal end user, like, if that's such a thing, doesn't even open his computer. So if you have a laptop, you basically don't have SATA. The docking station, like the PCB that goes at the back, it's actually dual USB and SATA. So you can put both types of drives. The problem we have is that the 3.5-inch hard drives are a bit too long, and the robot cannot handle them. So until we make their own physical robots, we have to do with like small drives. And
Great question. Anyone else? Okay, then thank you so much once again. It was a great talk despite the meds, and a great video. Got the audio working.
cool, thanks.